Hello everyone, today we are going to solve Set B of first internal of computer oriented numerical methods. So let's start. Our first question is find the cube root of 12 using fixed point iteration method, correct up to 4 places of decimal. So we will start the first question. The fixed point iteration method involves finding a function whose fixed point is the solution to the equation. For cube root, we can use the function f of x is equal to 1 by 3 in brackets 2x plus 12 upon x square. So let's start with the first iteration. We will take x naught as 2 because the cube root of 2 would be clearly the closest to 12. So we are taking x naught is as 2. We will find the value of x1 in the first iteration, that would be 1 by 3 in brackets 2 divided 2 into 2 plus 12 divided by 2 square, that would be 14 by 6, and in decimal numbers if we find it out it would be 2.333 3, that would be up to 4 decimal places. And now in the second iteration we will put the value of x as the value of x1 that we took out in the first iteration. So our equation would be 1 by 3 in brackets 2 into 14 by 6 plus 12 divided by 14 by 6 whole square, that would be 2.2899 approx. Now the same we will continue. We will put the value of x2 as x in the third iteration, that would be 1 by 3 in brackets 2 into 2.2899 plus 12 upon 2.2899 whole square, that would be 2.2909 approx. Now same we will continue. We will put the value of x3 in place of x in the fourth iteration, that would be 1 by 3 in brackets 2 into 2.2909 plus 12 divided by 2.2909 whole square, that would be 2.2895 approx. Now as we can see that the answer for the third iteration and the fourth iteration are equal till first place of decimals, so we will consider this answer as our final answer and we will take 2.2895 as our final answer. Okay, so now we will continue with the second question, that is write an algorithm slash flowchart for finding square root of 12 using Newton-Raphson method. So for this question our equation would be x cube equals to 12, and the same for the function. Our f of x would be x cube minus 12 equals to 0, and we will take out the differentiation, that is f dash x, that would be 3x square, and the value of h would be f of x upon f dash x, that is we will put the value of fx as x cube minus 12 and the value of f dash x as 3x square. Now this is the algorithm for 12 for finding the square root of 12 using Newton-Raphson method. Now we would see the flowchart for the same. We will start with defining the function f of x, and then we will find out the differentiation of that equation. We will get the values of x naught and a and absolute error and maximum iterations. Now we will start a loop from iteration is equal to 1 to maximum iteration. We will, in the next step we would find out the value for h, that would be the f of x naught upon d f of x naught, and then we will subtract it from the value x naught, that would be our x1. Now we would print the value of number of iterations and the x1. In the next step, we would compare the value of absolute h and absolute error. If the value of absolute error is greater than the absolute value of h, we would absolute error is greater than we would print the solution, and then the our algorithm would stop. And if it is false, then we would put the value of x naught as x1, and then again we would start the loop until the value of absolute error is smaller than the value of absolute h. We will print the solution and then we will stop the loop. Okay, so now we will start with the third question. Give the output of Gauss-Jordan algorithm for the given matrix. In the first step, we would find out the in. So what happens is in Gauss-Jordan method. What happens in Gauss-Jordan method is that we have to make the diagonal elements as 0, and then we can find the solution of the equations that would come out. So in the first step, we have done R2 is equal to R2 plus 2R1, R3 would be R3 plus 1 by 2 R1, and R4 would be R4 plus 1 by 2 R1. We will apply these formula and we would get the next matrix. Now we would apply R2 is equal to minus 1 by 6 R2, R3 would be R3 minus 15 by 2 R2, and R4 would be R4 minus 7 by 2 R2. Okay, so again we would apply this formula and we would get the next matrix. Now we would apply R1 as R1 plus 2 R4, R2 as R2 plus 105 upon 71 R4, and R3 would be R3 plus 62 upon 71 R4. We would get the final matrix and we will pick out the equation from it and the values from it. Now the matrix is reduced in row echelon form, that is we would get the value of x as 36 upon 71, the value of y would be 307 upon 71, the value of z would be 128 upon 71, and the value of y would be 194 upon 45. Thank you.